Okay, so video 2 on lesson 3-4. All right, so we're going to start with example 3. It says a digital artist is reproducing a tire tread pattern from a partial tire print from a crime scene by applying a glide reflection. She uses the rule translate 0, 0.1 after you reflect across the y-axis to generate the pattern. Confirm that her rule could be applied to the partial pattern that was taken from the crime scene. Okay, so we're going to apply this to the picture. So remember that when you do compositions of functions, you go in this order first. We're going to apply the reflection first. Now, we're going to let this middle kind of stripe be your y-axis, just like if it was on a coordinate plane, right? The middle is the y-axis. So there's your y-axis, all right? And let's say we're going to use 2 tread marks. Let's say we use this tread mark over here, okay? Let's call that tread mark A. And let's use this tread mark down here. Let's call this tread mark B. Okay? All right. So we're going to reflect these across the y-axis. So that means that tread mark A is going to come over here. We're going to call that A prime. And tread mark B would come over here. And we'll call that B prime. Okay? And now we need to translate it up 0.1. What this means is the distance here between this tread and the tread where A is, this must be a difference of 0.1, so that when you do slide up, this is tread A double prime, and again, if we slide this up 0.1, this is tread B double prime. And this confirms, right? This confirms that if you apply this glide reflection, you can recreate this tread. So this confirms it. Okay. So next, we're going to talk about another thing about rigid motions. All right. So this one says a rigid motion is either a translation, reflection, rotation, or glide reflection. Right. So these are all of the different rigid motions. There are none others. And again, the idea is that these four, a reflection, translation, rotation, or glide reflection, these 4 will preserve angle measure and distance. Now I want to mention, I actually remade this video because I want to mention this glide reflection. Some people teach that the glide reflection should be in this order. You should do the reflection after you do the translation. You're going to see that it doesn't matter which way you do the glide reflection. All right, the composition comes out the same way. So be aware of that, and you're going to see me do that. You're going to see me do that in the last example here. So I just want to make sure you made a note of that. That glide reflections can be done in either order. Okay. All right. And then this last one here, it says any rigid motion can be expressed as a composition of reflections. Right. Reflections is where it's at. These guys control the translations and the rotations. So if you do in 3-2, if you reflect across 2 parallel lines, you end up being a translation. And remember that translation moves a distance of 2d, where d is the distance between the 2 parallel lines. And in 3-3, we talked about 2 intersecting lines. And these intersecting lines, sorry about that word lines, where they intersect, that is the center of rotation, and this is a rotation, 2 times the measure of the angle in between the intersecting lines, 2x. So there you go. Okay, so let's do one more. So it says, what is the glide reflection that maps triangle JKL onto triangle J double prime, K double prime, L double prime? So again, for this glide reflection, we are going to do the translation first and the reflection second. So I'm going to use blue here. So first off, you have to see that if I slide this triangle JKL to the right, I can line up the coordinates vertically, right? This is not oriented. You can see it's obviously flipped. But at least I can line K up, L up, and J up. So if I move K 1, 2, 3, for 5 to the right, plus 5. 5 to the right to this point here. There's where K prime could be. I move J5, 1, 2, 3, 4, 5. There's where L prime would be. And I move J5, 1, 2, 3, 4, 5. There's where J prime would be. Notice that if I connect these 3 dots with dotted segments to make this triangle, notice I am now this triangle J double prime, K double prime, L double prime, but now I'm flipped, right? But you can see vertically, I can just flip. So this is the first idea I'm going to do. So I'm first here going to do a translation to the right 5. And now I'm going to connect a pair of corresponding vertices. Let's just do the K's. So K prime to K double prime. This is a length of 1, 2, 3, 4. The line of reflection goes through its midpoint. The midpoint is right there. If we do the same thing with the J's, J double prime to J prime. 1, 2, 3, 4, 5, 6. Halfway is 3. 1, 2, 3. There's the midpoint. Connect those two midpoints. This is going to be your line of reflection. This line of reflection has a y value of 1. That is that line of reflection. So your second step here is you're going to reflect across the line y equals 1. And again, this is your glide reflection. So my final answer here is going to be, I'm going to do a composition. I'm going to reflect over the line y equals 1 after I slide or translate a distance of 5 to the right and 0 up and down on triangle JKL. And I'm going to get triangle J double prime, K double prime, L double prime. And again, you could reverse this if you want to, yeah? So you could also have reflected this first. This L would have gone 1, 2, 3, up 1, 2, 3, and then slid it 1, 2, 3, 4, 5, and there's L prime. So again, if you reflect it, L prime would have been up here, and then slide it 5, and there's your L double prime. So again, it doesn't matter the order that you do these glide reflections. Just wanted to emphasize that in this video remake. Okay? All right, very good. Thanks for watching. We'll see you next time.